Hello, sir.
Hello, am I audible?
Yes, sir. Good evening.
Good evening. So in last class we were discussing, I think JEE question, right? Do you remember the last question we have discussed?
So we were discussing NEET questions.
NEET question. So any doubt from the last class?
No, sir.
So I think we were
Sir,
discussing.
sir, this is my first class with you.
Nabil, it's your first class, right?
Yeah, sir.
Okay. So we are just in the, we are doing the first chapter itself. So no issues.
First chapter of 12th.
Yeah, 12. You are in class 12, right?
Yeah, I'm in 12th.
Okay. So we were discussing electric charges and field. So, uh, when we will discuss the other topics, that will not be issue for you. But those topics which you have missed, you may practice. I will give, need questions. We have assignments also, and you can ask any doubt from those topics. Okay. So we have assignments there in the portal also, which we have discussed in the class. So you can practice those questions and also need previous year question, and you can ask me individually if any doubt remains. It's only one or two topics, so no issue, you will understand it. And now itself the first chapter is going on, so you will understand the things. So it's a matter of practice. You practice those questions. If you have any doubt in those first two topics, ask me. I will explain it.
Yeah,
Okay.
sir. Sure. Yeah, sure.
Also, there are some assignments in the portal, so you can download that and you can practice. And if you have any doubt, you can ask in the class. So Krishna, what was the last question we were discussing?
So from a point charge, yeah, question number 29.
29. Okay, this one, right? So if you see, Naveen, we have discussed these topics. These were NEET questions. We are discussing NEET previous year question. So we have discussed this topic 1, charges and Coulomb's law. Then we have discussed topic 2, electric field lines and dipoles. Okay, so we are in topic 2 itself. There are 3 topics. So we will start the next new topic. So that will be, start for everyone. So from that, all are in same page. So previous 2 topics you have to practice and ask me the doubts. Okay. Maybe. So 29 we have done, right,
Sir,
Krishna?
no, sir. I think until 31 also. 31 we finished.
Oh, 31. Okay. So 31 we have finished.
32 also, sir.
Okay. 32. So the last one, I think, the meaning 33.
Yes, sir.
All of you go through this question number 33. So I think Akshay, this is also your new class, first class.
Yes, sir.
Is this your first class or you have done
First class. Sir. First class.
first class? Okay. So you know what is the basic concept of the classes? We are mainly doing the previous year questions. Okay.
Okay, sir.
So the concepts mainly we know. We have done. All of you have done chapter first. So most of the concepts, the formulas, So what I am doing is I am going through the previous year questions and I am explaining you the question through the concepts. If any new concept
Okay.
arises, I am explaining in the class on that spot. If we are going from problem to concept. So first we are doing questions and which those concepts which are new to the students or new from the NEET point of view, we are explaining those concepts.
Okay,
So
sir.
here nothing is like you have not studied or you have missed class, nothing like that. You all know the concepts. Here you are learning how to apply those concepts for previous year's question. Okay,
Okay, sir.
that is the basic idea of this course. So everyone attempt the question number 33, then we will discuss. So Akshay, you are preparing for NEET or JEE? Akshay, you are aiming for NEET or JEE?
Sir, JEE.
JEE. And Nabil, you are aiming for
JEE, sir.
JEE. So this is the questions of NEET. First, we are doing NEET question. After that, we will do the JEE question for chapter first. So I think Krishna, we have done some JEE questions also, right? Of first chapter.
I think no, sir. From the
We
beginning
cannot
itself, we were
discuss JEE
doing.
question. Okay.
No, sir.
So after this, we will discuss the JEE question from very first. We will start JEE question. So that will be start for all of you. So that will not be an issue. JEE questions I have discussed in other batches. So I remember that. So in this batch, we have to start JEE question afresh. Okay. So first we will do the NEET question. So all of you go through question number 33. Have all of you gone through the question? The question 33 says, there is an electric field E in X direction. If the work done on moving a charge of 0.2 coulomb to a distance of 2 meter along a line, making an angle of 60 degree with x-axis is 4 joule, then what is the value of electric field? So anyone having any clue how to solve this question? Any idea?
Sir, we can find potential difference and then we can find electric field.
We can find, who is telling? Akshay. So you are saying first we have to find potential difference, then we can find electric field. Okay. Anyone else? So let us first understand the question. Then we will go I will ask some, how to apply the question or how to solve the question. I will ask you the question. So first, let us understand the question number 33. According to the question 33, there is an electric field in X direction. So first we will draw a line. Suppose the electric field is along this direction. Here is the electric field. According to the question, electric field is along X direction. Okay. Then it says, if the work done on moving a charge of 0.2 coulomb through a distance of 2 meters along a line making an angle 60 degree with x-axis. So we have a line. According to the question, we have a line which is making an angle 60 degree. We have a line which is making an angle of 60 degree. This direction is along x-axis and electric field is along this direction. Electric field is here along x direction. Not here, we can see here x direction. Now question says, there is an electric field in x direction if the work done on moving a charge 0.2 coulomb through a distance of 2 meters along a line making an angle of 60 degree with x-axis is 4 Joule. So suppose we have a charge Q and this charge is moved along this line. Suppose we have a charge Q and this charge is moved along this line through a distance of 4 meters. Suppose this point is O and we are moving from O to A. Then work done in moving from O to A is given as four Joule. And this distance is 2 meters, not 4 meters. This distance is given as 2 meters. So when we are moving 2 meters along OA, the work done in the question is given as 4 Joule and the value of charge is given as 0.2 coulomb. If you see the value of charge which is given at 0.2 coulomb, then we have to find the electric field. We have to find the electric field. What is the value of electric? So any concept comes in mind to anyone, you can say me how to solve this question. You can express your ideas. According to Akshay, we have to find the potential difference and then we can find.
Nabil.
Achha, who was that? Sorry.
Nabil.
Achha, Nabil. According to Nabil. Anyone else who want to share his idea or his concept, whatever comes in mind? Samaira? Okay. So, what I am trying to explain is, we all know the formula. Mainly, we all know the formula. And from the first class, I am saying that actually 80% formula we know, but we don't know how to apply those formula and what formula has to be applied in which question. So we have to identify that. And what is my aim is, I am trying to explain you how to crack a question, how to go through that question, and how to identify the formula, which formula should be applied in that question. So how to proceed for that. So I will explain you that in each and every class and each and every question. So here we will see. Here, work done has been given in the question. If you see, the work done is given, charge is given, and also distance is given, right? Distance is also given. And we have to find electric field. So what comes in mind is we have to find electric field and distance is given. Distance is given means R is given and E is given. So we have, and also work done is given. So work done is a basically mechanical term, but if you see in electrostatics, work done is related with potential. Work done is basically related with potential. So if you see in the question, three things are given. Potential is given, distance is given, electric field is given. So if you remember the formula you have studied, the concept you have studied, you know a formula which relates between electric field, potential and distance. Which is that formula? Anyone? Can you remind what was that
E is equal
formula?
to dv by
E equal to
dx.
V by L.
Correct. E is equal to dv by dr. That formula we know. But here is a twist. We also have angle. We also have angle. This is valid only when electric field and distance are in same direction. When we have angle, we rearrange this formula and we write it as dv equal to E dot dr. The same formula modified to this one. dv equal to E dot dr. Everyone understood this? The actual formula is this, but we take angle 0 degree when we are moving along the field. Then in that case, we write cos 0. Here we write and we write this formula. So the actual formula is dv is equal to E dot dr. Everyone know this?
Yes,
Sir,
sir.
one question, sir. Why are we using dv instead of normal v, sir?
Pardon?
Why are we using dv instead of normal v?
You know, dv, actually dv is the change. It includes change. You know, if you go to the concept in deep, actually potential of a absolute point is not defined. Something like, you know, some kind of like physical quantities like potential energy or potential, these are not defined for a absolute point. So generally, when we take potential energy or potential, most of the time we are taking change only. Absolute potential is actually not defined for any point. You understood what I am trying to say? So most
Yes,
of
sir.
the time we will take change. If you want to define absolute potential of a point, you have to take one reference point and take that potential 0. So that will come on later stage. So most of the time we will define dv or delta v or delta u for these quantities to indicate change. To indicate change. Actually, this indicates change in potential. Actually, what happens when we are moving it through a distance dr, there is a change in potential. Dr is also a change. So this is also a change in potential. Understood?
Yes, sir.
So here, what will happen? We will write dv is equal to E dot dr. It means E dr cos theta, where theta is the angle between this electric field and this displacement. Theta is the angle between E and dr. Now, if you see in the question, what is the angle between electric field and displacement? Electric field is along x direction and we are moving along this direction. So obviously the angle is 60 degrees. So we will take E. What is the dr? What is the value of dr? Anyone?
2.
2
Correct.
meters.
Here is the distance 2. And cos, what is the angle? 60.
60 degrees.
Correct. Now, here is the problem. Here we don't know dv actually. So for that, what formula we have to use? Anyone?
dv equal to dw by q.
Correct. dV is equal to dW by Q. Potential is itself defined as charge work done per unit charge. So from here we can write. I'm going to the next page. We got dV is equal to E into 2 into cos 60 degree. Here we will write, again we will write dV is equal to dW upon Q is equal to E into 2. What is the value of cos 60? Half. Here we can add since dV is equal to dW by. So from there you can write dW is equal to Q into E. 2 and 2 cancels out. What is the value of charge? It is given as charge is given as 0.2 coulomb. So I will put here 0.2 into E, and in the question work done is given as 4 joule. Work done is 4 joule. So I will let 4 equal to 2 upon 10 into E. So from here we will get electric field as 20 volt per meter or Newton per coulomb. What is VVC unit? So here it is given in. You can also write Newton per coulomb also, same unit, volt per meter or 20 Newton. So if you see here, correct answer is D, 20 Newton. This one is NEET question. It was asked in 1995. So have everyone understood this? How we find the electric field? Anyone having any doubt?
No, sir.
So this we all know formula, but sometimes what we write, sometimes we merely write dV by dr. We don't take angle, or sometimes students may take sine theta or something. So in that case, we end up with a wrong result. So we have to see the angle, and we have to identify how to, only to use cos theta. Sometimes students by mistake use sine theta. So in that case, they ended up with a wrong result. So this was the method how to solve such type of question. Okay, moving to the next question. So anyone having any doubt? Should we move to the next question?
Yes, sir.
Alright. So from this we have completed topic 2. Now we will move to topic 3. Electric flux and Gauss law. So just go through question number 34. All of you go through question number 34. Electric flux and Gauss law question. It has been asked in 2019 NEET Odisha question. Have all of you gone through question 34? Anyone having any answer? It's NEET 2019 question, just 2-3 years. So the question 34 says, a sphere encloses an electric dipole. A sphere encloses an electric dipole with charges plus 3 into 10 power minus 6 coulomb and minus 3 into 10 power minus 6. Two charges are there. Next part is, what is the total electric flux across the sphere? The question asked is, what is the total electric flux across the sphere? In the question, we have given charge and we have to find flux. So what concept comes in your mind? What we should apply? Anyone? You have given charge, you have to find flux. So what concept?
Gauss law.
Obviously, we should apply Gauss law. Gauss law relates between charge and flux. So let us understand the question through a diagram. According to the question, there is a sphere, a spherical a sphere. So there is a sphere. First, we will draw this sphere. Like there is a sphere, and there is a dipole inside this sphere. We know what is dipole. Dipole is a combination of two charges, minus Q plus Q. That we all know. And
Sir, you're not audible.
am I audible? Sorry, there was a power cut off. Am I audible to everyone?
Yes, sir.
Yes, sir.
So now we see. Now we have to find flux through this sphere. So now we have to apply. Someone told me that we have to apply Gauss law. That is correct. We have to apply Gauss law only. So what Gauss law says? According to Gauss law, what is the flux? Flux is charge enclosed upon epsilon naught. That is flux. So what is the charge enclosed here? This is basically Gaussian surface. The spherical surface becomes Gaussian surface.
It charge is zero, right, sir?
Correct. The charge is zero. Whenever there is a dipole inside a surface, net charge is always zero. If you see here, that is plus charge and minus charge. So net charge should be zero and the flux should be. So whatever be the magnitude of charge, that doesn't matter. Whatever be the magnitude of charge, that is independent of magnitude. If there is a dipole inside a sphere, flux will always be there. So here, same thing. The flux will be zero. Everyone understood this? Anyone having any doubt? Everyone got this? How we got flux zero? If you see
Yes,
Yes,
option
sir.
C, C is the correct answer. Everyone understood this? Anyone having any doubt?
Yes.
Please ask. Okay. Next, moving to question number 35. So all of you go through question number 35. That is also somewhat related to flux and constant. So go through question number 35. Have everyone understood the question number 35? So according to the latest understand first what question says. According to question, the electric field in a certain region, the electric field in a certain region is acting radially outward and is given by E equal to A into small a. A charge contained in a sphere of radius A centered the origin of the field will be given by. So electric field is given. If you see in the question, electric field is given and value of electric field is given and we have to find charge, correct? And we also have a region. We have a spherical region. So let us understand it through the diagram. So first understand it through the diagram. What is question is saying? According to the question, suppose we have a spherical region like this. Suppose we have a sphere and it says that electric field in the region is A into A. Means it's a variable. Electric field in the region is variable. So suppose and electric field is radially outward. Electric field is like this, right? Electric field is like this. Value of electric field is equal to A into The electric field is variable, where A is the radius. What is A? A is radius, small a, and capital A is constant. Capital A is a constant. Now we have to find the charge which is at the center of the sphere. So basically, if there is a radial outward electric field, there must be a charge. There must be a charge inside the spherical surface. Suppose that charge is Q. So we have to find this charge Q. Here the difference is that if you see from first question, what is the difference here? In the first question, charge was given and we have to find the electric field. Here, electric field has been given and we have to find the charge. Everyone understood the question? Anyone
sir.
having doubt in the question? Please tell. And here electric field is also varied. So anyone having doubt in the question? If all of you understood the question, so please tell me how to proceed for this question. Anyone having any
Sir,
clue or concept?
sir, we can say E is equal to Q by 4 pi epsilon 0 R square. Then R we can substitute by small a. So, and E we can substitute by capital A small a. So capital A small a is equal to Q by 4 pi epsilon 0 small a square. And bring it to the LHS, we have A as capital A small a cube is equal to as capital A small a cube into 4 pi epsilon 0 is equal to Q, which is the charge.
We are saying that we have to put value of electric field as Q by R is 1 by 4 pi epsilon naught Q by R square, right? And in place of
Yes,
R,
sir.
we should put A.
Small a.
Small. Okay. Okay. Anyone else? So let us first see what we have to find, what we have given. So charge, we have to find the charge, electric field. So obviously one thing comes in mind is that we have to apply Gauss law. This is for sure. We have to apply Gauss law. This is for sure. Anyone having doubt in this? Why we have to apply Gauss law? Here electric field is given. It means we have to find flux of electric field and charge we have to find. So here one thing is clear that we have to find Gauss. We have to apply Gauss law. So now, right, if you see right hand side, there is nothing to find out. Only we have to find charge Q. Epsilon naught we already know. So there is no bothering about right hand side. So the thing which has to be found out or which has to be calculated is flux. So here main concept lies how to find flux. Right or wrong? The
Yes, sir.
main concept
Yes, sir.
is to find the flux of the electron. If you will find flux, no issue, you will get the charge increase. Now, your question arises how to find the flux. So we know the basic formula of flux. What is the formula of flux? Anyone can say?
ED
E
is cos
dot
theta.
ds. E dot
E
ds
dot
radius
d.
plus theta.
Correct. The correct formula is actually E dot ds. That is also correct. Good. Now, suppose the radius of this sphere is A. So this will become Gaussian surface and we have to apply Gauss law over this surface. Whenever you apply Gauss law, you must find the Gaussian surface. So here Gaussian surface will be a spherical surface of radius A. It's obvious since we have to find the charge enclosed within the sphere of radius A. So here our Gaussian surface is going to be a spherical surface of radius A. That is also clear. Now, there is a point in the question which is very important. It's saying that the electric field in the region is radially outward. It is mentioned in the question. How it is useful for us? Anyone? How this term is
So
useful
there is
for us?
positive charge inside. That's why.
Positive, that is also a point. Apart from that, that is also point radially outward means there must be a positive charge. That understood. But if you see from this point of view, I am saying how it is important. You can, that is also a matter of question. So you concluded that there is a positive charge. Apart from that, how we can use that? Think about it. Here we have dot term. If you see,
Yes,
here
sir.
we have
Angle
dot.
between the electric field and the ds is 90, right? Because it's radially outward.
You're going in right direction. There is a little twist. Think again. If you see, like how when we remove this dot product, we write it as EDS positive, right? So if you see here, the electric field is radially out. And what is the direction of DS? DS is also a spherical surface over here, a small portion. And to find the total flux, we integrate it. So DS is almost away from the sphere, right? And if the surface is a spherical one, the direction of DS should also be radially outward. Getting my point or not?
Yes, sir.
Yes, sir.
If you say a spherical surface, and if you take any small area on this surface, the direction of area, that is normal. So if you draw a normal, the direction of ds is along the normal. So direction of normal should also be along radial direction, since it is a spherical surface. So this theta should be equal to 0 degree. I will also give you a clue here. If you are getting angle as 90 degree, if you see the question number was 35, right? If here you can see there is no term like 0, right? I'm explaining how to reduce the options sometimes, which I am explaining time to time. See option A, B, C, and D. There is no term like 0. If you take angle 90 degree, the charge will become 0, right? Since if you are taking angle 90 degree, this term will vanish. This term will vanish, and the charge will become 0 degree. Here no option is 0. So if you are doing that kind of mistake sometime, you must, one thing should come in your mind. Here no option is 0. Say I am getting somewhere wrong. You're getting my point, what I'm trying to explain.
Yes, sir.
Yeah. Here angle should be 0. So the flux will become like EDS. So E, and what will be the area? If you see total area, if I'm trying to, here I am saying this is a small portion of the area, but we have to find the flux through all the surface, right? So if I calculate the total value of ds, what will be that? That should be 4 pi. What is the spherical area? 4 pi a
R
square.
square.
4 pi a square, not pi a square. Everyone getting this? Why I'm taking 4 pi a square? The surface area
Yes,
of
sir.
a spherical surface is 4 pi. So now 90% of the calculation is completed. we have to put the value of phi. Phi is equal to Q by epsilon naught. And what is the phi we have calculated? E into 4 pi is equal to Q by epsilon naught. Now what we should do? Put the value of electric field, that is A into A, and it is 4 pi A square, and that is Q by epsilon naught. From here we will get the charge. Q should be equal to 4 pi AQ A into epsilon. Everyone understood this? How we got 4 pi AQ A epsilon naught? Anyone having any doubt, please ask.
Sir, in the starting I had told, right, we should substitute E by capital A small a and use the formula, but instead of R we substitute small a. Then what's the same answer coming, sir?
Sorry, I'm not getting. Can you repeat
Sir,
again,
in
please?
the starting I had told, for electric field as given in question, we can say capital A small a, and for E is equal to Q by 4 pi epsilon 0 R square. So instead of R we can
You
substitute
are
small
saying
a.
we put the value of electric field 1 by 4 pi epsilon naught Q by R square, and in R square we should put
Yes, sir.
this, right? And
And then
A
we
into.
equate.
Okay, you are saying that from that also, or we are getting same result, 4 pi AQ epsilon naught
Yes, sir.
A. 4
Yes,
pi
sir. Same
A
answer.
AQ epsilon naught. That is also, here we will get 4 pi epsilon naught AQ A. And the value of electric field is given as A. This
No,
is
sir, we
also
can.
correct. This is correct, but you know, this practice is actually, if you see for this question, that comes out to be true. We are getting the answer. That is very good. But this practice may not work sometimes when here in the question it is given that here we don't know now the kind of charge we don't know. If you see in the question, there is nothing has been mentioned that the charge is point charge, right? And here we are taking electric field of a point charge, which we are making assumption, right? Here we are putting the value of electric field of a point charge. So fortunately, that comes out to be true. That is good thing. But this we should not keep this in practice. Sometimes we may get wrong result, or we may end up with a wrong result. For this question, we are getting the right result, but radial electric field can also be for other configurations, and for that charge configuration we don't know the value of electric field, so we can't write the electric field. Here we have already assumed that there is a point charge at the center, and for that electric field is this. You are getting what I'm trying to say?
Yes, sir.
So sometimes we are getting the kind of right result by applying some other concept, but I will suggest you to do that one. Apply Gauss law. That is always correct. Whatever with the electric field. Why why I have not used that formula is that if you see in the question, the electric field has given as A into A. So if the electric field is radial, why it is increasing with A? If you see here, electric field is increasing it with A, right? So how we can say that the charge at the center is point charge, right? It should decrease. It should be A by A or A by A square kind of thing. So, are you getting my point?
Yes, sir.
So that's why I have not used that formula. But for this particular kind of situation, we are getting the right result. But you should keep practicing Gauss law. Gauss law is the better kind of concept to apply for such. And you will not end up with a wrong result when you will have the habit of applying Gauss. So anyone having any doubt apart from this,
No,
please
sir.
ask, or we should move to the next question. So let us see what is the correct answer. 4 pi AQ A epsilon naught, 4 pi AQ A epsilon naught. I think B is the correct answer, right? All right. Anyone having any doubt? All of you, Nabil, Akshay, Krishna.
No,
No,
sir.
sir.
No, sir.
Okay. So if you have anyone, Samaira, anyone having any doubt, please. So moving to the next question, that is very important question also from this question was also of JEE main level. Such type of question may be asked in JEE main. Question number 35. Now moving to the question 36. That is also this type of question has been asked in JEE main frequently. So go through question number 36. Have everyone understood the question number 36? What it is saying?
Yes, sir.
Okay. So according to question number 36, what is the flux through a cube? What is the flux through a cube of site A if a point charge Q is at one of its coordinates? So according to the question, let us understand it through a diagram first. According to the question, we have a cube. Let us first draw a cube. According to the question, we have a cube and there is a charge at the corner. Suppose at this corner, we have a charge Q, a small q. So at this corner, we have a charge small q. So obviously, because of this charge, there will be electric field everywhere. If you see, this electric field will be in radially outward direction in all the direction in a spherical symmetry. We know electric field due to point charge is of spherical symmetry. So obviously it will go through like that radially in all directions. So what we have to do is there will be some flux associated with this cube. Some part of the electric field lines will pass through this cube. So we have to find flux of those electric field passing through the Q. Everyone getting my point?
Yes, sir.
So tell me how. Anyone? Anyone having any idea how to solve this question? Such type of questions also asked very frequently in JEE also. And I will explain you how to solve such questions, and you will not going to forget these uh, kind of questions. Many questions are there, like sometimes the charge will be at the center, sometimes at the corner, time at the surface, so kind of. So first understand this question. You know, if if you if you see you have given a charge and you have to find the flux. So one thing is sure that we have to apply Gauss. It is sure we have to apply Gauss. Again, I will not write Q like we have to find flux, right? We have to find flux. So I will write here like so. Here main thing is that from where or how to find the flux and how to select the Gaussian surface. The main thing will the main point, or say, you can say that the most important thing over here will be to select a Gaussian surface, and you will learn the concept of finding the Gaussian surface or how to select a proper Gaussian surface for a particular charge configuration. So the concept of Gaussian surface is that it should be symmetric. We all know that, but we don't know how to use this term. Gaussian surface should be symmetric, always symmetric. If you see, when I have taken a spherical surface, I put the charge at the center. No, if charge is at the center, we take a spherical Gaussian surface. Why we take a spherical Gaussian? Because it is a symmetric surface. It is equivalent for all the directions. It is equivalent for all the directions. Here, if you see in this case, someone will say that, sir, here also I will take a spherical Gaussian surface. Will it be true if I take a spherical Gaussian surface here? Anyone? Can I take a spherical Gaussian surface here? Obviously, no. If I will take a spherical Gaussian surface, that should also match with the configuration of the structure or configuration of the cube. We have to find, ultimately, we have to find the flux through the cube. So our Gaussian surface should also be symmetric with the cube. Getting my point? If I will
Yes,
take
sir.
a spherical Gaussian surface, that will not be symmetric with the cube. If I take a cylindrical Gaussian surface, that will not match with the symmetry of the cube. So here, since cube has been given, the Gaussian surface must also be a cube that will match with the given configuration. Now the point will come how we should select a cube such that this charge which is placed at the corner should be symmetric. So let us draw a new diagram. Again, I am drawing a cube. And I have to select a cubical surface such that this point becomes symmetric. It means this point should be identical from all directions. So what we can do is I will take a cubical surface like that on this cube. Here it is also not symmetric. So I will surface again like here. Again, it will not be symmetric. This portion is empty. So here we should also take a cube. In the similar way, now we are having 4 cubes on the front side. So we should also have 4 cube on the back side. Getting my point? Now you see the central charge is now symmetric at a symmetric position from all the cubes. Now see, this charge becomes symmetric or not?
Yes, sir.
Yes, sir.
Yes, sir.
So our Gaussian surface should be such that the charge will be at the symmetric position. So this whole cube, which is a combination of 8 identical cubes, will be Gaussian surface. So this structure is actually our now it becomes very easy to apply the Gauss law. What Gauss law says?
Q by Q
Gauss
is
law says
phi is equal to
total
Q by
flux.
epsilon 0.
Correct. Phi is equal to Q by epsilon naught. Okay.
In Gaussian
Now,
cube, we will get phi is
yes,
equal to Q by 8 epsilon 0.
correct.
Because one of the
So,
8 cube.
yes. So here is the phi through the Gaussian surface should be Q by epsilon naught. Now we have to find flux through this surface on. Like, so suppose phi flux through each cube is phi. So in this Gaussian surface, there are 8 such units. How many units are there? 8 units. This Gaussian surface is made up of 8 units of such Gaussian surface, red one. So here we can write 8 into phi should be equal to Q by epsilon. Therefore, flux through each unit will be equal to Q by 8 epsilon naught. Have all of you understood this one?
Yes, sir.
Yes, sir.
Yes, sir.
So this is how we proceed for such kind of question. Why this come one by? Generally we, by heart, if it is at the corner, 1 by 8, if it is at the center, Q by epsilon naught. But sometimes we may get to the wrong result if we don't understand the concept. Why it is come 1 by 8? That is the reason. So let us see which option is correct. If you see, option B is the correct one. Here there is a typing mistake. Here E0 is written. That should be epsilon. So the correct answer is B. Anyone having any doubt, please ask. So the correct answer is B. Q upon eta. So whenever you are placed, the charge is at the corner. It should be 8 by epsilon. Q by 8 epsilon. Okay. So all of you understood this? Samaira?
Yes, sir.
Okay. Share. Nabil, everyone?
Yes, sir. Understood.
Yes, sir.
Okay. Moving to the next question. 37. So go through question number 37. So question number 37 says a charge Q is enclosed by a Gaussian spherical surface of radius capital R. Full stop. If the radius is doubled, then the outward electric, so charge is placed at the center of a sphere, radius is becomes double, then we have to see how the flux changes. So anyone having any answer or kind of clue how to solve this question?
Sir, it will be same, sir. Gaussian surface is independent of it is independent of the area.
Gaussian surface is independent of the area. Why? Surface area depends upon radius. If you increase in the flux, E dot ds, area is changing whenever radius is changing. In the terms of E dot ds is the area. So whenever radius changes, area also changes. Anyone else? Okay. So let us see. According to question, there is a spherical surface and there is a charge at the center. Suppose flux through this surface is phi. What is the value of phi? Q by epsilon. Correct? Suppose its radius is a. Now what happens? We made it double. Radius become double. Charge Q is at the center. Radius become 2a. Now we have to find flux. What will be phi? What we have to do? We have to apply Gauss law. Here, how we find flux? We applied Gauss law. Again applied Gauss law. What it will say? Q by epsilon naught. Flux will remain same. So you were actually right, but you are unable to explain how you are right. Getting my point? Who was saying the answer, Nabil, or who was saying?
Yes, sir, me, sir.
So you were correct. Flux will remain same, but you have to say that the flux here from the Gauss law, the flux is Q by epsilon naught, and we have to find flux only. So here it is, area. We don't have to find area or something. Only we have to find the net charge enclosed by the surface. So whoever is its radius, whosoever is the radius a by 2 or a or 2a, the charge enclosed by the Gaussian surface remains same in both the cases. Charge enclosed doesn't changes in configuration 1 or 2. Here charge enclosed was Q, here also Q. So flux will remain same. Getting my point? So
Yes, sir.
what actually happens is, if you see from the physics terminology, what happens is, like I am drawing circle, like suppose I am like this, then suppose I have a sphere like this, 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 I have a sphere like this. Suppose I place a charge Q at the center. So electric field are moving like that, like this. And we have different surfaces. If you see here, like we have surface 1, 2, 3, 4. From each surface, all the electric field lines are passing. Getting my point? Either radius increases or decreases. Each of the electric field lines are passing all the surfaces. Either it is surface 1, either it is 2, 3 or 4. So because of radial nature of electric field, it has to be passed through all the surfaces. It is independent of radius. If you see number of line passing through each and every surface is same. Getting my point or no? That's why the flux remains same. Getting my point?
Yes.
Yes, sir.
So that was from Gauss law. Gauss law also says phi is equal to Q by epsilon naught. But if you see from physics point of view, actually this is happening. That is why flux remains same. Okay. So it will remain same. Correct answer is C. Okay. Now move to question number 38. So everyone go through question number 38. This is a very tricky question and easy also. Such type of questions are important for both JEE and MENS. These type of questions. So each of you go through this question. 38. Have all of you gone through question number 38? So question number 38 says a square surface of side L, a square surface of side L meter in the plane of the paper is placed in a uniform electric field E, acting along the same plane, at an angle theta with the horizontal side of the square as shown in figure. Okay. The electric flux linked to the surface is, means we have to find the electric flux. So let me explain you the question, what it is saying. There is a square. First I will draw a square. Let's suppose we have a square like this. And in this region, there is electric field like this. Like this. So electric field is like this, and in the question it is given that this electric field is making angle theta with the horizontal line. Suppose this is horizontal direction. So this line is making angle theta. Okay. An electric field is like this. And in the question, it is given that side length of this square is A. Side length of this square is A. Then we have to find the flux of the electric. What is the flux of the electric field? Obviously, electric field is fine passing through the surface. So there must be flux. So what is the value of flux? Everyone getting the question?
Yes, sir.
Sure.
Okay. Now the thing is that I will explain you two methods to solve this question. First, I will solve by general method. Then I will give you a trick to how solve such question. Coming 3 or 4 such type of question. So you can solve in a, on your fingertips. So first I am giving you the normal method. Method 1, how to solve such question. Method 1. Here, there is a clue given in the question. In the question, it is said that uniform electric field acting along the same plane. The question says that there is a uniform electric field acting along the same plane. Same plane. Same plane. What it means? It means if you consider the plane of the board or this plane of the screen as the plane, so square and the electric field both are in same plane. Suppose I say this plane is XY plane. Suppose this plane is XY plane, then electric field as well as a square both are lying in the XY plane. Both are in the same plane. Getting the point? Okay. So the general how we find flux here, can we apply Gauss law? Anyone? So if you say method one, what is that? What it is? We have to find flux. So what is the formula for flux? We know that phi is E dot delta S. Getting my point? So what is the direction of delta S? Direction of delta is always along normal. Direction of area vector is always along normal. So here, where will be the direction of delta S? It should be perpendicular to this plane of this square. It means it should be like that here. It should be perpendicular. Means the direction of delta S should be along Z direction. It should be along Z direction. Everyone understood this?
Sir, can
The
you
area
repeat, sir?
vector,
Yes, sir.
area vector should be along Z direction. It means the angle between, it means the angle between E and delta S will be 0 or 90.
0.
Why 0? Electric field is in XY plane. Electric field is in XY plane and normal is along Z direction. So it should be 90 degree or not. Since
Okay.
Sir,
area
can you say
vector,
why it is in that direction, sir?
whenever we are taking the direction of area, it is always perpendicular to the plane of the surface. Whenever we consider area vector on a surface, like suppose we have area like this. So when we take area vector, that area vector is always perpendicular to the surface. That is the concept of area vector. Area vector is always perpendicular to the plane surface on which we are taking the area vector. Getting my point? That is the concept of area vector. The direction of area vector should always be perpendicular to the surface. So in our case, the surface is along XY direction. In XY plane. In our case, the surface is in XY plane. So area vector should be along Z direction. Getting my point?
Yes, sir.
So here angle between and electric field is also in XY plane. So here the angle between electric field and area vector should be 90 degree or not?
Yes, sir.
Yes,
It
sir.
means flux will be 0. Getting my point or not? Area vector is perpendicular to the electric field. So flux should always be 0. So here the correct answer is D. No need of theta, nothing, no use of theta. Theta is here extra data. Everyone understood this or not? Anyone having doubt, please ask. Anyone having doubt, please ask.
Here, sir, here flux is 0 because cos 90 is 0, right, sir?
Yes,
Okay, sir.
angle between electric field and area vector is 90 degree. So this is, I am giving you the second method how to solve this question, method 2. Very quickly. What is method? Method 2. Apply Gauss law. Method 2. Apply Gauss. What Gauss law says? Phi equal to Q enclosed by epsilon naught. Is there any charge enclosed by the surface? Here you see, is there any charge? Is there any charge within the surface? Obviously
No,
not.
sir.
Electric field is coming from outside. Electric field is coming from outside the surface and moving outside. So net charge in, what is the net charge enclosed? 0. So flux should be equal to 0. Getting my point?
Yes,
Yes,
sir.
sir.
So whenever,
Yes, sir.
also you can understood it like this. If you see here, if you see this one, see total number of flux. What number of electric field line is going out, same number of electric field lines is coming in. So net flux is always 0. The number of electric flux field line entering the surface is equal to number of electric field line going out. So net flux is always 0. Getting my point? So without
Yes, sir.
solving and going through any calculation, you can directly say that in such cases, whenever there is a closed surface, flux will always be 0. What is this? It doesn't matter what is the shape of the surface. If it is like this, and if there is a uniform electric field, flux will also be 0. Or if it is like a cube placed in a uniform electric field is going like this. In this case also flux will be 0. So whenever there is a closed surface placed in a uniform electric field, flux will always be 0. All of you got this point? Whatever
Yes,
be
sir.
the shape of this.
Yes, sir.
So for today, I am ending up here. If you have any doubt, please ask. I will also give you some assignments which will be available on the portal. You can download there, and we will meet with the next question and new concept in the next class. So anyone having any doubt,